A public health researcher examines the medical records of a group of 937 men who died in 1999 and discovers that 210 of the men died from causes related to heart disease. So, first off, I know that the probability of dying from heart disease is going to be 210 over 937. Okay, so let's continue. Moreover, 312 of the 937 men had at least one parent who suffered from heart disease. Okay, so that tells me that the probability of a parent that struggled with heart disease was 312 over 937. Okay. Um, of these 312, 100 died from causes related to heart disease. So, the probability of dying from heart disease, given that one of your parents was inflicted by heart disease, right, is going to be 102 over 312. So, that's the information that I got from this paragraph here, right? So, let's see what they want us to calculate. Calculate the probability that a man randomly selected from this group died of causes related to heart disease. So, probability died given that neither of his parents suffered from heart disease. So, P complement. All right. So that's what they want us to figure out, right? Well, using the definition of given, we know that this is the same thing as the probability of D intersection P complement over probability of P complement. And of course, I can get P complement in terms of P. That would help. So this is the same thing as, well, let's see, D intersection P complement. So I have D. I probably want to rewrite this in a different way. So let me draw a little bubble to help me. So let's see. Little sample space, right? So let's see, we have D and P. Oh, and P. Okay, so D intersection P complement is this right here, right? D intersection P complement would be this. So we can rewrite this as the probability of D, right? This whole thing minus the probability of D intersection P all over 1 minus P, the probability of P. All right, well, I can actually figure out the probability of D intersection P from this equation that I have here. So let me go ahead and scoot up a little bit. So I have that 3, 1, 2. Oh, I'm sorry. I have that 102 over 3, 1, 2 is equal to the probability of D given P. And I know that this is equal to the probability of D intersection P over the probability of P. And I do have the probability of P. So this gives me 102 over 312 is equal to, so the probability of D intersection P over, so the probability of P was 312 over 937. And now what I can do is I can actually multiply both sides of this equation by 312 over 937. 312 over 937. And then these 312s cancel, so I'm left with 102 over 937 is equal to, and then these cancel here, the probability of D intersection P. Now I have D intersection P, and I can plug everything, because now I have everything in the thing I'm looking for, right? So let me go ahead and go down here. So remember, I'm looking for the probability of D given P complement, which I found out to be the probability of D minus the probability of D intersection P all over 1 minus the probability of P. Well, the probability of D, right? I know that's 210 over 937. So 210 over 937 minus, and I found the probability of D intersection P, 102 over 937. And that's all over 1 minus the probability of P, and the probability of P was 312 over 937. All right, so I can plug this into a calculator. I'll do the top first. This will give me 108 over 937. And the bottom, 1 minus 312 over 937, would just give me 625 over 937. This is equal to 108 over 937 times 937 over 625. The 937s cancel. Then I'll have 108 over 625. And that is approximately equal to 0.173. And that is answer B, right?